Hello, Mr. Candor. My name is Amanah, and the topic that I've decided to analyze is cholesterol levels and what negative consumptions that may increase the levels of it. The question is what is the truly biggest factor when assessing increased cholesterol level? To get more of an accurate representation and to truly see if there is a trend within both variables chosen, 30 random countries have been selected for data purposes. Considering this project is based around cholesterol, a little insight on the term will help. Cholesterol is a waxy, fat-like substance that's found in all cells of the body. The components that we will be discussing in this presentation are why I sparked an interest for this topic, where the collected data that made this whole project happen come from, thesis questions, and hypotheses made prior to gathering the data, a data analysis of each chart for my primary variables, being alcohol and smoking, an analysis of the scatter plot between alcohol and cholesterol and smoking and cholesterol, and of course, a conclusion. So to start off this presentation, I have chosen to assess how smoking and alcohol consumption affects cholesterol levels in hopes of helping my aunt to quit smoking. I hope to show her this presentation to open her eyes to the serious health issues that may arise from smoking. The methodology used in my assignment included gapminder.com to collect all the data assessed from 30 different countries and fathom to put this data into graphs and tables. To create an unbiased decision for my sample when choosing countries, I selected at random 30 countries from a list of every country in the world rather than choosing countries with data that matched my hypothesis. These two sources go hand in hand in the creation of the assignment because without one of them, there would be no assignment. The hidden deadly causes mentioned in the title are my one variables, which are smoking, alcohol consumption, and cholesterol. My two variables are smoking versus cholesterol and alcohol consumption versus cholesterol. All data was collected in 2008. The questions at large when comparing these pieces of data is there a relationship between levels of alcohol consumption and a higher cholesterol level, and if the higher the percentage of women who smoke will cause an increased cholesterol level. Prior to arranging data, I hypothesized that there will be a strong positive linear correlation between higher amounts of alcohol consumption and a higher cholesterol level, so the more liters consumed, the higher the cholesterol level will be, and that there will be a strong positive linear correlation between the higher the percentage of women who smoke and increased cholesterol levels, or the more you smoke, the higher your cholesterol level will be. When analyzing the histogram and box plot that represent cholesterol levels, it is clear that the information is left skewed. The lower the alcohol consumption rate is, the higher the frequency is. The mean of calculated cholesterol in the bloodstream of women in given 30 countries is 4.456 millimoles per liter. It is also evident that quartile 3, or the 75th percentile, being 4.7 millimoles per liter, and quartile 1, or the 25th percentile, being 4.23 millimoles per liter, are very similar. The similarity in values means that, for the most part, the data collected from the 30 countries are all very similar. The interquartile range of the data is 4 millimoles per liter, while the standard deviation is shocking 0.3 millimoles per liter. In this case, the interquartile range seems to be a better fit for the representation of this data, being that it is most similar to quartile 1, quartile 3, mean, and median. The range of the whiskers in the box plot also represents the largest and the smallest numbers, so the range is within 1.5 millimoles per liter, making the analyzed data very strong. No outliers seem to stray from the data as well, which is demonstrated in the range and how tight-knit it is. Since the data is, for the most part, constant among all 30 countries, a possible reasoning that could be that cholesterol isn't more prominent in some societies over others, but is pressing in any country that you live in. The mean and median are identical in that they are both valued at 4 millimoles per liter, which assists in helping the point that this is a heavily correlated piece of data. The histogram and box plot provided for the alcohol variable is seemingly left skewed as well. For the most part, as the x-axis being alcohol increases, the frequency of alcohol consumption increases as well. The mean of the alcohol consumption in the 30 countries analyzed is 5.5 liters. The value of the 25th percentile is 2.27 liters, and the value of the 75th percentile is 7.86 liters. As you can see, the values of the quartiles are very far from one another. This means that data from the 30 countries vary from country to country and show no trend when compared to each other. The interquartile range of the data is roughly 6 liters, while the standard deviation is 4 liters. In this case, the mean is exactly in between the interquartile range and standard deviation, so both, in my opinion, would represent the data effectively. The mean of the data is roughly 5.5 liters, while the median is roughly 4.5 liters. There is not much to compare between the median and the mean, but that they are 1 liter apart, which means that they are fairly similar to one another. The whisker on the box plot reaches out to around 13 liters, with a clear outlier at 17 liters. This outlier may have been formed from a country that's culture is heavily influenced by alcohol, causing the average alcohol consumption per person to fluctuate, in contrast to countries that may have strict religious laws against alcohol and forbid it in their country. Gaps are present between 13 liters and 16 liters on the graphs, in which the cause of this could be, as mentioned previously, a country that consumes an above average amount of alcohol because of culture. Smoking variables box plot and histogram show that the data for percentage of women who smoke in the 30 countries analyzed is very left skewed. The lower the smoking percentage is, the higher the smoking frequency is. The mean of smoking women in the 30 countries analyzed is 6%. The median, on the other hand, is 3.2%, a significantly lower number than the mean. Out of the two, the mean logically is the most accurate to determine the average of a set of data because its job is to summarize the properties of a group of data such as the one for smoking. The median, though, represents a typical percentage of smoking amongst the 30 countries and therefore does not hold as much accuracy as the mean does. When looking at quartiles, quartile 1 is 2.2%, while quartile 3 is 7%. A range such as this represents a set of data that has a wide range of percentages. Not only are quartile 1 and quartile 3 so far from one another, but several outliers and gaps are about. The interquartile range is 6% and is more representative to the data than both the standard deviation, which is 7%, due to the fact that interquartile range is most similar to the mean, in which the mean is a literal calculation of the average of data, which ultimately causes it to be the most accurate representation of the data in its entirety. The box plot ranges from 0 to 15 with outliers at 17, 25, 30. Gaps are also present in the histogram between the outliers and the main data points. Outliers and gaps so large can be explained by possible overly stressed countries. It is proven that stress causes people to take on habits, excessive smoking being one, and even if stress has been alleviated, smoking is highly habitual. So, countries that have been proven to hold more stressed citizens than other countries may be the explanation to these outliers and gaps in the data. When analyzing the scatter plot, it is evident that there is a positive linear trend line through the points. The equation of axis is y is equal to 0.0204x plus 0.2588. Since the r value is 0.2588, the correlation between the data is weak. If you look at the scatter plot, you can see a trend, but very faintly, with outliers that range from the bottom of the plot, which is 4.1, to the top of the plot, which is 5.2. It does demonstrate that the more alcohol that countries consume, the higher level of cholesterol is, but not significantly. The analysis of the scatter plot between the relation of percentage of smoking women in 30 countries and cholesterol levels, there is a positive linear correlation. The equation of axis is y is equal to 0.0221x plus 0.48. The r value of the scatter plot is 0.48, which means that there is a moderate relationship between the two data points. The data points reveal that, for the most part, the higher the percentage of smokers there is, the higher the level of cholesterol. It is clear that my hypothesis was incorrect. Neither of the scatter plots represented a strong correlation, in which smoking versus cholesterol was moderate and alcohol versus cholesterol was weak. My hypothesis did hold truth, though, when analyzing the direction of the scatter plots, as both showed to have a positive correlation. The cause of data such as the ones analyzed could be that the data collected in each country did not accurately represent the country, as a survey may have been only given to a sample of women, and some women even may have not taken the samples because they are embarrassed of their habits. In order to attain an accurate representation of the correlation, a larger sample in each country should be taken. Thank you for your time, Mr. Kandor, and have a great day.